No, we can do that from here. Let's go with the right side view just to make it different. Okay. Okay, so the first thing we're going to talk about next is the type of geometry that you can use for the different operation types. In our product, there's basically 5 different types of operations. There's hole making, there's 2-axis operations or 2.5-axis operations, 3-axis operations, 4-axis operations, and 5-axis operations. I'm going to go through the geometry requirements or options for each one. And we're going to start with hole making. We are going to be drilling and tapping some of these holes. So the minimum requirement to drill a hole is a point. Now we've got circles, okay, that illustrate our drilling operations. That's fine. You can use a circle. It'll calculate the center of the circle for your drill point. If you don't have circles, just create a point and you can use that, okay? For 2.5-axis operations, at minimum, you need a 2D drawing like we have, or just some curves that you have drawn on the screen. Those curves need to be on the XY plane, okay? It can be above the XY plane. It needs to be parallel to the XY plane. The CAD program will project them down to the XY plane when you actually create the operation. You can use a 3D model to do 2-axis operations. Any curve, any edge of a surface, or any basically edges and curves in a 3D model, when you pick those, it'll project those down to your XY plane, or where you're actually going to be drilling or cutting in what level, okay? So for 3-axis, you have to have a minimum of a surface, a poly surface, or a NURB surface, or a mesh, okay? So you can machine a mesh or surface. For boundaries, you can, to contain your drawing, you can use curves, okay? 4-axis is very similar. For the index 4-axis, that reverts to the requirements of either the 2 or 3 or hole making, whichever operations you do in a fixed orientation on that 4th axis. So for 4-axis fixed, you can revert to the requirements for hole making 2-axis or 3-axis. For simultaneous 4-axis operations, you do need a surface or a mesh to calculate those continuous 4-axis operations. In 5-axis, you need either a surface or a mesh similar to 4-axis. It's a little bit more to understand in 5-axis, because if you do continuous in the index 5-axis where you're rotating in planes, that will revert back to the requirements of whatever you put in that indexed fixed orientation. Drilling, 3-axis, revert back to those requirements. For 5-axis, if you're going to do continuous 5-axis or surface milling, you do need to have a surface, obviously, or you can do it with a mesh. If you're doing a continuous toolpath operation in 5-axis, you have 2 different types of geometry types. You have drive regions and check regions. So your drive regions needs to be a surface to calculate the normal direction of the spindles, because the spindle is going to orient itself in an orientation that's at right angles to any point on that drive surface. So that's what's going to orient the spindle for you. You can't do that with a mesh. You got to have a surface. You got to have preferably a NURB surface. And the check surface is just simply the mesh or the surface that you don't want the tool to violate. So that's pretty straightforward if you have a 3D surface model. If you only have a mesh model, then you need to add your drive surface. Typically, you can just put a cylinder inside your mesh, and you can use that cylinder to orient the spindle, and then it won't violate the mesh if you define it as a check surface. I'm not going to get into too much about the 5-axis. We have we actually have a case study coming up that's going to illustrate that, and we have plenty of webinars and blog posts to cover that. So we've got to get back to our drawing. we've got a 2D drawing, and we're going to be camming this drawing based on this cross section. So I'm going to be going a little bit slow. If you have any questions, go ahead and put them in the questions panel, and let's go ahead and get started here. So the first thing we're going to do, start from the left, work your way to the right, just like any new CAM job. Our machine is not going to change. It sets the 3-axis, whether they have 3-axis or 2.5-axis. So we don't need to do anything there. The post, I already have it set